we are going to work on limits. I really like trig, and I really like the idea of limits. It kind of goes back to the idea that we learn math, sometimes not for the purpose of learning math, but for, I guess, not for the purpose of real life, but for the purpose of being able to apply what we know to a new situation. And that's what trig limits are really about. Back in chapter 1, we talked about functions that are continuous. In other words, things that don't divide by 0. And if you're continuous, you know that the limit equals the function value. So here, when your function is continuous, you just plug in the x value and you get an answer. So as you get closer to 5, the answer is 3 because the function is continuous. We also know that if you have a limit that exists, but the function is not continuous, there's algebra we can do to simplify our expression. So when you have the 0 divided by 0 situation, you cancel out the factors that are causing divide by 0, and you plug and you get an answer. So as you get closer to 5 on this function, this rational function, as x approaches 5, you get closer and closer to 2/5. But the point 5 and 2/5 doesn't exist, but the limit exists. So we're gonna talk about things being continuous, things not being continuous in our lesson with trig limits. So here, boy, sine theta and cos theta are the foundation for math, because of course they relate to tangent and cotangent and all those things as well. But we're going to talk about sine theta as a continuous function. As you approach 0 from the left side, it approaches 0. As it approaches 0 from the right side, it approaches 0. So the closer and closer sine theta is to 0, the closer and closer you are to 0. Okay, because that's that idea of being a continuous function. And the same thing with cos theta. If you approach from the left side of 0 or the right side of 0, you get closer and closer to 1, because cos theta is also a continuous function. These examples on the first page here now are all about the functions that are not divided by 0. So that's always that's kind of your first test. Are you dividing by 0 or not divided by 0? And if you're not dividing by 0, you're continuous, which means your limit is the value of the function. So these 6 examples are simply examples where you plug in the value that you're given, and then you just use your previous trig skills. Sine of pi is 0, cos of pi is -1. And hey, something that we should maybe mention is we do not use degrees in any kind of higher math or higher sciences. It's always radians. And the reason for radians is, if you think back to your definition of radians, it's an arc length divided by radius. So there's no units involved in radians. And when you start taking rates and derivatives, it's real important to know that radians need to be used so you don't get an extra rate into your problem. So anyways, everything we're going to do here is going to be about radians. So that's kind of the first part of trig limits, is when things are continuous.